And welcome to the Mathly YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
All right, so we're going to be talking about 12107 power question. We're going to talk about problem number 4. So this problem was what we wanted to do is there are two things. One was to part A was to prove that mu of x is multiplicative, and part B was to prove that mu of x is not completely multiplicative. All right, so first off, let's talk about what these terms mean. So multiplicative means that, okay, let's write this down. So that means we're given relatively prime x and y. We have mu of xy equals mu of x times mu of y. All right, so first off, it is really important to note this relatively prime part. And the reason for that is because, in fact, if x and y are not relatively prime, this ends up being false. So speaking of terminology again, if completely multiplicative means that we're given any x and y, we have mu of xy is equal to mu of x, mu of y. All right, so let's go to part A and prove that mu of x is multiplicative. So we have three cases to deal with. One of which, case 1, we have that either x or y is equal to 1. Yeah, or at least one of. And without loss of generality, let's say that x is equal to 1. So that means that we have then that mu of 1 times y is equal to mu of y. And since mu of 1 equals 1, we have that mu of 1 times y is equal to mu of 1 times mu of y. So that takes care of case 1. Case 2, we have that x and y are both relatively prime square-free integers. All right, so what that means here is that since, they're both square-free, that means that therefore we have that mu of x is equal to 1 and mu of y is equal to 1, or plus or minus 1, sorry. Okay, so and then from there we can then conclude that mu of xy will again be plus minus 1, depending on the parity, so then that we'd get our xy is then mu of xy, mu of y. And then case number 3, we have that at least one of xy is not square-free. So basically, and we can say that without loss of generality, that x is not square-free. Now, it's possible that y might be square-free or y might not be square-free, we don't know. But regardless, this then means that mu of x equals 0 and mu of y equals anything, we don't know. And then mu of xy, then x is equal to 0 because xy is not square-free. And of course, 0 times anything is 0, so we again get mu of xy is equal to mu of x, mu of y. All right, so now let's go to part B, and we need to show that mu is not completely multiplicative. So what's important to note here is that this time, since we're proving something in the negative, is not necessarily true. It suffices to provide one counterexample. All right, so the reason why I can provide an example here is we want to show that this is not true all the time. So if we can show that it's false just once, we're good. However, that's not the case for part A. We can't just give like one example to show that something's always true. All right, so now when we provide this one counterexample, we can just find anything. There are multiple ones that work. For example, we can say that let x equals y equals 6. Then we know that since x and y are both square free, mu of x and mu of y are equal to plus minus 1. However, mu of xy is equal to mu of 36, which we know is not square free. So that's going to be then just equal to 0. And obviously 0 is not equal to plus or minus 1. So there we go.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.